trigonometry. In trigonometry, we are going to learn about triangles. That means in trigo, be establishing the relationship between sides of a right angle triangle and angle of a right angle triangle. Okay. First, we are going to learn some terms related to right angle triangle. Then we study trigonometry. What is the role of trigonometry to finding the angles of a right angle triangle? We will see later on. First of all, we are going to learn some terms. If suppose this is a right angle triangle, right angle at B, right angle at B, okay. If we consider this as a theta, then in right angle triangle, this is known as the adjacent side of a right angle triangle, okay. This is known as adjacent side, and opposite to the theta is known as opposite side of a right angle triangle. Opposite side of a right angle triangle, okay. And opposite to the right angle is known as hypotenuse of a right angle triangle. Hypotenuse. If suppose we consider this theta, then this one is adjacent and this one is opposite, and opposite to the right angle is hypotenuse, okay. But we are going to understand all formula related to this theta, okay. Adjacent side is also known as base of a right angle triangle, and opposite side is known as perpendicular of a right angle triangle. Now we want to find angle, or if we want to establish the relation between these three sides, then we introduce trigonometry, and we have 6 trigonometrical ratio which are used to establishing the relationship between sides of a right angle triangle and angle of a right angle triangle. These 6 trigonometrical ratio are sine, cosine, tangent, cotangent, secant, and cosecant, okay. These 6 trigonometrical ratio establishing the relation. Sin theta is establishing the relation between perpendicular and hypotenuse of a right angle triangle. That's why sin theta is also called opposite side upon hypotenuse, okay. And this is also known as P upon H. Cos theta or cosine of theta is establishing the relation between adjacent side and hypotenuse of a right angle triangle. Adjacent side upon hypotenuse. That means this is nothing but B upon H. Similarly, tan theta establishing the relation between opposite side, that means perpendicular, and base of a right angle triangle. That's why tan theta is known as P upon B. Cotangent establishing the relation between base and perpendicular of a right angle triangle. Also here see, this is inverse of tan theta. Cosec theta establishing the relation between hypotenuse and perpendicular of a right angle triangle. That means this is nothing but H upon P. And secant, that is sec theta, is establishing the relation between hypotenuse and base of a right angle triangle, okay. These 6 trigonometrical ratio are used to finding the theta of a right angle triangle. If someone given the sides of a right angle triangle and say find the 6 theta, then we are going to use Pythagoras theorem to finding the third side of a right angle triangle, because in right angle triangle we use Pythagoras theorem to finding the sides of a right angle triangle if two sides are given. Okay, according to Pythagoras theorem we know that h square is equals to p square plus b square. H is hypotenuse, p is perpendicular, b is base. That means h is nothing but under root of p square plus b square. Suppose someone say if base of a right angle triangle is 4 and perpendicular is 3, then find sine theta. Then first we are going to find hypotenuse of a right angle triangle. Okay, how we find? If p and v are known, then we can easily find h. H is nothing but 4 square plus 3 square. Then this is nothing but under root of 16 plus 9, that means 5. Under root of 25 is nothing but a 5. Okay, this is 5. We want to find sine theta. What we learned sine theta is nothing but relation between perpendicular and hypotenuse. That means sine theta is equals to p upon h. That means sine theta is nothing but 3 upon 5. Similarly, we are able to find all trigonometrical ratio with the help of